everyone, in this video we're going to start talking about the odds. So why we need to focus on the odds. Okay, so I want to emphasize that in the previous video we look at using the minute stay outdoor to predicting the respiratory illness. And in the logistic regression, we are able to see these two coefficients, right? The y-intercept and also the partial coefficient, 2 minutes. So one thing I want to calling out that is when we try to interpret in this 0.0056, as you notice that in the last video, I didn't bother to interpret it because it is not as what we thought as before, which is if x increased by 1, how y will change. And it's no longer like that due to the functional form change. So this is very important that if you want to interpreting this partial coefficient in the logistic regression model, you cannot use what we already learned before to look at it because it's not linear regression model anymore. So therefore, we need to use a different approach. We call it odds. So before we dive into the odds, I want to talk about a little bit about the problem of our partial coefficient here. Okay, so when you look at that partial coefficient for the key variables, what you can see is whether they have a positive or negative relationship. Just whether increasing them will increase the probability of getting illnesses, whether if it's a positive. If it's become negative value, you're looking at if the increasing that value will decrease the probability of getting that illnesses. So the sign still have the same meaning. However, if you try to give more quantifiable interpretation on that partial coefficient, it becomes challenging. So because it does not imply a unique partial effect of that variable on your predicted probability. Okay, so therefore here we're going to talk about how you should correctly interpreting that partial coefficient of in your logistic regression. So let's revisit the example which I show you as our first example, using the number recipient, the number hyperlink, the number character to predict that whether the email is a spam or not. Like I said, here we kind of do a comparison between linear probability regression model and the logistic regression model to give you a sense about the differences. But again, as I emphasized that from now on, if you see the binary outcome, you should choose logistic regression. As we're learning here, allow you to do a good comparison. We're going to compare these two together. Okay. And then the second is use simulation to highlight the partial effect of the recipients on the predicted spam probability while holding the hyperlink and the characteristic fixed at their spam means. Okay, so there's two ways to interpreting this partial effect from this specific variable, such as the number recipient or the hyperlink, is using a graph. Okay, after introducing the graph, we're going to talk about the odds. Okay, after we run the regression on Excel, we are able to obtain the result for the linear probability model, LPM. And then we use a Python or R, and we are able to get a result for the logistic regression. Okay, so for LPM, it's straightforward. So basically, holding on the variable not change. If the number recipient increased by 1, the probability that email is a spam will increase by 0.01. Okay, however, we cannot do that for the logistic regression. It doesn't work. Again, because that functional form is totally changed. So what can we do is that we can creating a diagram to showing as one of the variable holding other variable not change. If one variable change, how will that impacting the probability at the end? So here is an example. And so we did the same thing for LPM so that we can compare these two models. But again, for the LPM, you can just interpret directly using the regular linear regression model to interpret the partial coefficient, but for the logistic you cannot. Okay, so what we did is we are holding the number of the hyperlinks and the characters not change, and so we are using their average value. So we plug in the model, and then we are varying the number of the recipients from 10, 20, 30, 40 to 50. So we're varying them so that we are able to predict that probability. So we predict the probability based on a PM model, and we also predict the probability based on the logistic regression model. So those are the predictions. And then based on that, I'm able to plot. Okay, so this is what I plot. As you can see, the LMP is a straight line up. As you can see, once we get into the 50, almost close to 50, the probabilities start to explode. which is above the 1, which we think that's accurate. So therefore, as I said, logistic regression is the best way you should do when you see the binary outcome you try to predict. So for the logistic, as you can see, that is capped. You can keep going further and further. So this curve will never cross this 1 horizontal line or go below the 0 horizontal line. So always going to be within that band. So as you can see here, let me go back. When we predicted the recipient, the logistic regression model is 0.1075. So as you can see here, you cannot say as the recipient increased by 1, my probability of the spam, it's a spam email increased by 10%. As you can see, that's not the case. It doesn't increase by 10%, right? So therefore, that's one thing I want to emphasize, that when you interpret the partial coefficient for the logistic regression model, you cannot use the regular method we learned before to interpret it. So here, this diagram show you why, right? So it doesn't make sense. So what is the best way to do is convert that to the odds. Okay, so hopefully in the QB2, you cover the odds. Otherwise, you actually already know odds in your daily life. So if you like see the horse gambling, no, I'm not encouraging everybody to go to watch a horse gambling, but that's what they usually report it. It's odds. Okay, the odds means the probability of the winning divided by the probability of the losing. So that is the odds. So basically, usually people say the odds of winning a game, right? So means using the probability of the winning divided by the probability of losing. That gives you the odds. Okay, so therefore, when we found a way to interpreting our partial coefficient, it is converting the coefficient to the odds, and then we are interpreting it as odds. So the estimated coefficient of logistic regression model does not allow us to determine the partial effect of the predictor variable on the probability. It is preferable to interpret the logistic regression coefficient in terms of the odds rather than probability. So the odds is formed as the numerator is the probability of the outcome you label as 1 divided by the probability of the outcome you label as 0. So if I use the previous example about the spam email example, since the spam, if it's spam equal to 1, if it's not spam equal to 0. So therefore, the odds when we try to create here is the numerator is the probability of the spam divided by the probability of not spam. So that's going to become my odds. Okay. So the odds metric is especially popular in the gambling, sports, and epidology, because a lot of our outcome is really related to the binary. Okay, so therefore, when you are running to the model that the outcome you try to predict is binary, nobody will be surprised that when you're reporting the business outcomes related to this called odds. But the one thing, based on my personal experience, I use a lot of logistic regression in my industry job. I noticed that a lot of people actually had a hard time to understand the odds. So therefore, I think sometimes it's a good idea to show them example. Okay, so later when we look at example, I can give you some tips in terms of how to communicate odds to your stakeholders. So the transformation from probability to odds, and odds is a monotonic. So implying that if one increases, the other one decreases. So therefore, this is really good. So why do we care about odds in the context of logistic regression? So it is easy to interpret logistic regression coefficient in terms of odds. Basically, the predicted probability of the success is basically you just plug in, right? So that's P. And then the predicted probability of the failure is 1 minus whatever you predicted. So the odds become the following: exponential B plus B1 x1. And so the natural log, take both, and natural log, you basically find that the natural log of the odds give you the linear regression model we already learned before. So again, you don't have to really familiar with the math deduction. That's why before we never covered this part in the undergrad level learning, because the math part is crazy, make people getting crazy. However, as I said, as AI developed, a lot of model can be run by the AIs, but you need to know as analysts how to interpret results. Therefore, we are focused on, hey, how can we interpret my result if I'm given this output from somebody else? So what we're going to do is that when we're getting our partial coefficient, that B, and then we're going to do is we take exponential and then minus 1 times 100. That's going to give you, as B change by 1 unit, how will that impact in the odds of the success. Okay, I know it's a little bit confusing at this point. Let's look at example and then you know how to interpret it. Okay, here they go. And again, we are using that spam email as example again. Okay, so this is the output. We already seen before. Again, we focus on the second column, logistic regression. My recipient is 0.1075. In order to interpret that, we need to do some transformation. So the transformation we did is following. We are taking a exponential of my odds, this value 0.1075, and then minus 1 times 100, and you will be able to obtain this number is 11.35%. So that basically means the percentage change in the odds as a recipient increased by 1 unit is 11.35%. So basically, if we have one more recipient adding to the email, the odds of that email being a spam will increase by 11.35%. And we can do the same thing for the hyperlink, keep other variable not change. If the hyperlink, the number of hyperlink increases by 1, and the chance for the email being a spam will increase by 67.07%. Similar for the characteristics, characters. So so here is a typo. So the parenthesis should be here instead of there. Okay, so if the holding out the variable not change, if the email have one more characters, the probability for the email be a spam will decrease by 1.4%. Okay, so that is how you actually should interpreting the partial coefficient, which is really different from what we did before, right? Before, we can just directly using that if it's a linear regression model. But now, as a logistic regression, first of all, you need to know that it's no longer predicting the probability. The partial coefficient is used to need to do some conversion to look at the 1 unit change on their variable, how that impacting the odds of being the outcomes. Okay, so in the next video, we're going to explore a little bit about accuracy, because we need to compare to understand, hey, before when we look at how model fitting the real world, we use R-square, but for the logistic regression, is R-square still be a way to measure it? If not, what other thing we can use?